MATLAB and Simulink feel intimidating only until you realize they are simply tools that let engineers think, test, and build without touching hardware first. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why tools matter, not just which buttons to press. Most students think MATLAB and Simulink are academic software used only for assignments and simulations, but in reality, they exist to solve a very practical problem: how to model, analyze, and validate systems before spending time and money building them. Engineers use these tools to predict behavior, catch mistakes early, and experiment safely in a virtual environment. To see this intuitively, think about planning a long journey. You don't start driving blindly. You check the route, estimate fuel, and plan stops. MATLAB and Simulink do the same for engineering systems. MATLAB allows you to analyze data, visualize results, and test algorithms step by step, while Simulink lets you build system-level models using blocks that represent real components like motors, controllers, and power systems. At a deeper level, MATLAB excels at numerical computation, data analysis, and algorithm development, while Simulink focuses on time-based modeling and simulation of dynamic systems. Together, they allow engineers to move from equations to simulations to implementation, bridging the gap between theory and real-world behavior. On a larger scale, MATLAB and Simulink are used across industries including aerospace, automotive, power systems, robotics, communications, and control engineering. Companies rely on them, design controllers, simulate power networks, test embedded systems, and validate designs before deployment. In real engineering practice, step-by-step MATLAB and Simulink projects are used to develop control algorithms, analyze signals, simulate machines, and prototype embedded solutions. Engineers who master these tools can translate ideas into working systems faster and with fewer errors. Now that you understand why MATLAB and Simulink matter, the next step is to walk through hands-on projects from scratch, where models turn into simulations and simulations turn into real implementations. And that's exactly what we'll cover next here at the Learning Studio.